Okay, we should be live. Okay, good afternoon, everybody. I'm going to go ahead and share my screen. So I'm going to put this in presentation mode. Okay, good afternoon, everybody. Welcome to AFCOM Southern California Chapter's second quarter 2025 educational series webinar. Um, and Before we get going on today's session, I want to give the opportunity for our board to introduce themselves. So why don't we start off, we'll go alphabetical order and then finish with Di so that she can give her IT recruiting update. So I guess David?
Hello, folks, and welcome to Q2's webinar. Great to have you all here. I'm David Sipes. I've been a board member since 2013, and been in the data center world for about 25 years. And I really welcome everybody to this webinar, and hopefully that you find it very fruitful for you. Thanks, Jason.
And Doug?
Hey, good afternoon, everyone. I'm Doug Allman. I'm the Network Operations Manager with Sempra Energy, San Diego Gas and Electric, and SoCal Gas. I've been part of the AFCOM SoCal board since about 2017. Last few years have been a little bit inactive, but recently trying to get back engaged with our local chapter.
And Yeet, why don't you introduce yourself there?
Hello, my name is Yeet Bullock. I'm with Rambo Data Center Facilities, formerly known as EYP Mission Critical Facilities. We're basically a global consulting engineering firm that can provide services in the built environment for everything from environmental through structural, civil, MEP design, which is what we specialize in. I've been a member of AFCOM for a number of years, and I've only been a member of the board for maybe the last 2 or 3 years. Hopefully this session is informative and everybody gets a little bit of something out of it. Thank you.
Di, why don't we have you give your update?
Oh, you want Todd to go?
Todd's sword's on too.
Oh, I'm sorry. Did Todd join on? I didn't see him join on.
Yeah, and we got Thomas Tate as well. So, yeah, Todd Sword, Southern California Edison. I'm in our Economic Development Services group, and I kind of specialize in helping large power users, including data centers, come to our territory. And Jason asked me to share one of the updates. Edison's actually stood up a special team called Ready Grid to see about being able to deploy large-scale power faster, for data centers and other customers. So we're excited to be able to have some opportunities and increase the speed to market that the industry is demanding. So thank you again for joining. I've been with AFCOM maybe 10 years now, but recently joined the board maybe about 6 months ago. So glad to be a part of it and hope you enjoy this webinar.
Howdy, y'all. My name is Tom State. I'm the data center manager for the San Diego Supercomputer Center. We host a variety of different supercomputers. We have liquid cooling. We have some special battery technology that's proprietary. So I'm, foot in the field here. Nice to have everyone here.
And Di, why don't we give your update, including your IT recruiting update too, please?
Hi, everybody. Diane Crabiel-Delson. I go by Di in the industry. I've actually been doing this for 25 years. I own DKKD Staffing, and I staff across the U.S. I got to say, in the past 25 years, this is probably the hottest year I've had for direct hire placement when it comes to leadership and IT roles, including HR. Wasn't quite sure when the year started off a little bit slow, but then February hit, and I'm staffing in all different industries, various departments. It's kind of funny because it's usually cyclical. It is a little bit different this year where I'm seeing more leadership roles now than I usually do in the beginning of the year. And of course today, one of our topics is going to be AI, and it's actually can be a big concern for us in the recruiting field because we get a lot of AI submitted resumes that we have difficulty seeing or checking to see if they're fake. We have to go through a lot more processes when we screen candidates, the video interviews, even if we video interview somebody, because it's more of a virtual world now, it's more video versus in person. We still have to make sure that the person is actually the person interviewing. So it's, it's been a common problem for many, many years. Now it's a little bit more prevalent. I got to say that we all have to embrace it and just understand it. It's impacting the data center world and it's impacting us as well. So we just have to understand it better, be aware, and figure out how to work with it in the future. And if you know people are out on the job market, I'm here to help them. If you're hiring, I'm here. And take it away, Jason.
Well, thanks, Di. So my name is Jason Shepard. I am the president of the AFCOM Southern California chapter board. Been on the board now. I guess I've been a member of AFCOM for over 20 years, but I've been on the board for now 11. David and I are the old timers on the chapter, and David is the actual treasurer of the chapter. And so the one thing I want to do is, first of all, right off the bat, is thank all of our board members for participating. We are a not-for-profit organization focused on education for the IT data center operations community here in Southern California. And so we need the volunteers like our board members here to help make this chapter go. What we're going to be covering today is we're going to be going through really kind of what's happened. Is two the biggest data center industry events have already happened this year. They typically happen every spring and or in the winter. So in January every year, there's the annual PTC, Pacific Telecom Council's data center conference in Honolulu. And then followed by the spring data center world in Washington, D.C. So I attended both the events. And so what I'm going to do today is share with you some of the trends that we're seeing that are being covered at each of these different industry associations. And I'm going to go through, quite quickly a lot of these different trends, and then leave some time for our board to discuss these trends. And our board is a combination of people that are in the industry, whether it's on the service side and DI in the IT recruiting and Yeet on the engineering side. Then you have some of the end users and so forth. But the whole idea is then get the commentary. Hey, what do we notice? What does our board notice about what's going on? What's most important to everybody? And then I also like to take some Q&A. And so if you do have questions, if you can please type those into the Q&A session there in the actual webinar. And we have some of our board members looking at that, and we'll make sure we'll field those questions. So first thing I want to be able to talk about, again, since we are a not-for-profit organization, this is not what our sponsorship packages are, but I was just, being that we have different chapters all across the country, I spoke at the Silicon Valley chapters event 2 months ago, and they had this is their 2025 sponsor package for their chapter. Ours isn't going to be quite as much, considering that we don't really have a golf tournament. But David and I are going to be, and the board are going to be working on a series of sponsor packages. If you're interested in sponsoring our chapter, we would greatly appreciate it. Normally our larger corporate sponsors for the chapter are on the co-location industry, but as you'll learn here today, that with vacancy rates, availability rates within co-location facilities being at record lows, there just isn't a lot of need to sponsor events by the different colos these days. So anyway, anything that your organizations could do to help sponsor our chapter is greatly appreciated. So a couple of things. We always address this right off the actual bat, is that when people talk about the data center industry, people keep talking about, hey, all these hyperscalers and what's Microsoft doing, what's Amazon Web Services doing, et cetera. But in reality, there's a Fortune 1000, and of that Fortune 1000, you maybe have 10 of those organizations, or less than 10 of those organizations that are in that hyperscale category. The rest of the corporations that are utilizing data center space are really in that corporate umbrella, right? So if you look at our Southern California base, our constituents, are really the brick and mortar companies that are headquartered in this marketplace, whether it's in San Diego, where 50% of the publicly traded companies headquartered in San Diego are in that bioscience, medical device, pharmaceuticals, manufacturing industry. Same thing in Orange County, the highest quotient of our publicly traded companies. Excuse me. Yeah, in Orange County, the highest portion is in biotech. Then you look at Los Angeles and so forth, right? So what we're trying to do is making sure that what we're basically doing in our chapter really applies to the enterprise users that operate within Southern California, if that makes sense. A couple of things that we've been trying to do for the last 3 years. We do one of our sessions like today's on the post PTC and post data center world initiatives or events. What trends do we notice across the different sessions? So at PTC 2022, you'll notice that there's sustainability. I'm sorry, this is 2023. Sustainability were and green initiatives were really the most reported on topic between the two conferences. Supply chain issues came in second, followed by cloud, edge, hybrid models, and we started seeing a little bit of AI. You fast forward to last year, the PTC and Data Center World events, you had a lot of topics on bandwidth and power infrastructure and energy, and AI moved one up the chain. Well, at this year's events, you'll see that AI is really kind of taken main focus by everybody. And so it's really impacting the industry. So what I'm going to do is I'm going to jump into showing everybody what's being talked about at these different events. Now, when you're looking at my screen here, anytime you see AI, chat GPT, virtual reality, artificial intelligence in general, I've kind of highlighted in that purple color. If it's just straight bandwidth, telecom, et cetera, I've kind of left it unshaded. Power, infrastructure, energy is that orange color, and anything which is cloud hybrid is that blue color. So if we were to look at the Pacific Telecom Conference's 2025 spring 2025 meeting there in Honolulu this year, when I went kind of by days, right? Sunday, it's the first day at PTC every year. I almost call it the telecom day, right? A lot of submarine cable discussion, telecom cabling discussions, a lot of research, but there was still a bunch of AI scattered in throughout the actual day. The second day at PTC, you started seeing a little bit more of the AI, a lot more of legal discussion, a lot of investor discussion. What was interesting, you finally get to the fourth day, and the fourth day was the first time we really kind of saw there's an entire AI communications summit, and also the i3 forum. And so just a lot of discussion on AI this year at PTC. So first thing I wanted to do is at PTC this year, the opening keynote presenter was literally Bill Barney, who is the chairman of overall PTC, the international organization. And before I kind of go too much further, I want to be able to talk about the difference between the PTC conferences and data center world conferences. PTC every year has historically been, I've been going for the last 5 years, and historically, this event is attended by most of the multi-tenant data center, the co-location operators. Most of the big cloud providers are there, and a lot of the telecom providers are there, and it's really international in nature, which is a far different attendee list than you see at a data center world. In a data center world, you have someone's trying to ring me. Sorry about that. I put that on. I just turn off my phone altogether. Whereas data center world itself is mostly attended by the corporate users, the co-location, some of the co-location operators, but a lot of the infrastructure community that builds data center facilities. Okay, so a little bit a different appetite between both the different conferences. So PTC, Bill Barney's opening keynote presentation on the views on the next century of the digital landscape. The thing right off the actual bat, and these are all notes we took from the actual event. Cloud was the biggest driver of growth over the last half decade, but in his comments, that AI will go even further and quicker over the next 5 years. Jumping down in the actual next comment, it's like just the hardware and software revenue that's expected to come from AI will equal the total revenue of the big three in the cloud sector at 1.3 trillion US dollars. So that's a lot of expected revenue coming from AI coming shortly down the actual pipeline. Um, Down to the bullet point I've highlighted down below regarding the arrival of AI. The AI came at a time when many people were thinking that the industry was starting to get kind of over bearing on the cloud side, looking for a massive reset. So going on to the actual next page, and this is just the same keynote presentation. I've got 3 slides of his keynote presentation. Global forecasted demand for new data center capacity, over 43% of that is coming from the actual hyperscalers. Um, Bill's comment here is like, if you look at the overall dynamics in the actual market, the digital infrastructure marketplace, it was looking frighteningly similar to what the trends were in the year 2000, where many of us who have been in the business for over 20 years or remember when we all took it on the chin in the year 2000 when the market imploded. That's a far cry from what's happening today. Digital infrastructure players surrounding hyperscalers were declining. Operators have actually seen decreased revenues over the last decade. Next comment here is total US data center electricity use from data centers. It's skyrocketing. What you'll see in the industry right now is data center demand is at all-time highs. The power industry is getting just absorbed. I mean, it's just getting overtaken right now by all these different data center requirements out there. There's a lot of green considerations that are out there. And his comment here, third from the bottom, the race for power is really on across the United States. Now, I'm going to share a couple things from my own research database from my own firm. We track all the utility power rates across the country. We've got about 20 years worth of running data, but we also are tracking all the utility power plants currently under construction across the country. And one of the biggest challenges here is the fact that there's only 26 gigawatts of power plants planned or under construction across the country that's coming from natural gas. Why do I mention that? Well, called 89% of the power that plants that are currently under construction or planned across the country are green in nature, and that's fantastic. The challenge with green is it's intermittent. It's not always on. It's great when the sun is shining and it's great when the wind is blowing. But for those 24/7 operations that the data center operations utilize, it's not necessarily the best match for scalable 24/7 operations load, if that makes sense. So again, there's just a significant demand for power across the country, and there's just limited power supply, if that makes sense. So let's talk next about Data Center World. So Data Center World 3 weeks ago in Washington, D.C., this was the leadership committee from all the presidents of each chapter across the country. I'm the tall dude right in the middle, the guy who's the one guy that's not smiling in this whole thing. So for whatever reason, bad timing for me. So anyway, let's talk about Data Center World. So Data Center World, these tracks are going to be slightly different because you have a lot more in the way of the data center operations side of the business, but still kind of overlaying the AI component and the edge component. Again, I've color coded a lot of the different sessions here. And again, the same thing here. This is then day 2. I skipped basically day 1 and day 3 because day 3 was a half day. Day 1 were all of the breakout, all the workshops that were one-on-one workshops. So first thing I wanted to do today was cover the first keynote session from Data Center World, and this was David Bell from VoltaGrid. And VoltaGrid is a supplier of on-site cogeneration type capabilities where they basically take natural gas feeds and they basically put it through a mobilized turbine and create power immediately on site. His first point here was under the escalating energy consumption of data centers. Currently, there's 176 terawatt hours annually consumed by data centers across the country, which is about 20 gigawatts worth of capacity. To me, that sounds light. But again, this is the research that they have. 20 gigawatts of capacity, which equates to about 4.4% of the total electricity, U.S. electricity capacity today. Okay. or I should say consumption today. Now, what David projects, and this is consistent with what the opening keynote presentation was at PTC, is that over the next 3 to 5 years, they're expecting that 176 terawatt hours to rise to 325 to 500 terawatt hours, or from 20 gigawatts of worth of capacity to 37 to 66 gigawatts of capacity, or between 6.7% to 12% of the overall total electricity consumption in the United States. That is significant. And remember, I just got done showing you that 26 26 gigawatts worth of natural gas plants planned across the country. So this is a real problem. We're running out of capacity across the country. We're running out of energy supply. I'm not talking about the actual 230 kV lines coming to your site, the 100 level kV lines coming to your actual site. I'm talking about the energy supply that the utility providers can send down the lines to your data center facilities. Okay, so what's next? There's a lot of discussion of at PTC and at Data Center World of microgrids behind the grid, meaning looking at having customers generate on-site cogeneration at their facilities, really to mitigate the power that they can get from their actual utility provider, if that makes sense. So data centers, the next bullet point here is data centers are currently using more natural gas than the cities of New York, San Francisco, and Chicago combined. That's a lot of natural gas consumption, okay? And so per David Bell, being closer to those energy supply basins are going to be better for those data center operators as they expand across the country. Now, the lower left-hand corner here, you're going to see that this is the current electricity generation across the United States, and you're still seeing that the two biggest buckets are the natural gas and coal, right? So this really starts to come into play when you start looking at there are 28 states across the United States, plus Washington, D.C., that have these renewable energy laws. It's not a nice to have, it's not a goal. These are required laws that require a certain amount of the electricity that's generated by the utility provider that comes from renewable or green sources by specified periods of time. Here in California, our renewable energy law is 60% by 2030, and then the balance has got to be green by 2045. That's had an impact on our utility rates here in California. The next keynote presentation that we had there at Data Center World was from NVIDIA. And NVIDIA talking about new terminology that we're now starting to hear, such as the AI factories. Okay, so that's what they're now calling AI data centers. Historically, we've looked at the data center market in three categories as far as data center operators. It's been corporate America. We called it enterprise data centers, right? Middle category, the internet data centers, also referred to as hyperscale data centers, right? And then the last category, we call them third-party operators. Wholesale colocation as a baseline might lead to a retail colocation provider who might have a managed services provider as a client, who might have a cloud provider as a client, who might have the enterprise user as a client. So that last category was I always describe like the Russian nesting dolls, right? One inside the next, inside the next. Well, there's been a new entrant to the data center community, and that's the AI data centers. So if you look at the traditional corporate data center using 3 to 5 kilowatts of power per rack, well, these hyperscalers are starting at maybe 25 kW per rack. And the multi-tenant data centers, the colo facilities, maybe starting at 15 kW per rack. Well, these AI requirements are starting about 40 to 60 kilowatts of power per rack. And when I flew back from PTC, I sat next to one of the executives at one of the big data center operators, and they were telling me they're seeing customers going from starting at, well, it's not starting, but they can range over 400 kilowatts of power per rack. So this is a very, very significant and different type of a model that we've previously seen in the actual data center industry. So a lot of great notes here. And what we'll do is we're going to share all of these slides on our LinkedIn page. And we're also recording this, and we'll upload this web meeting to our YouTube channel if you're interested in look at reviewing this again or looking at any more of the notes more carefully. The next keynote presentation at Data Center World, we had the head of clean energy and decarbonization at Google as a panelist with Kairos Power talking about the future of small modular reactors and how Google is deploying these for them to expand out their different for them to expand their data center platform. Now, let's talk about this again. Now, remember, for clean energy restrictions and green energy laws, so remember, renewable laws, so the state of California does not consider hydroelectricity to be renewable. It's got to be the wind, solar, or biomass, right? So many states, each of the different states across the country that have renewable energy laws, their different environmental protection agencies for their states have different definitions for what they consider to be renewable. So my point here is that when you start looking at different areas across the country and what their different RPS standards are, the renewable portfolio laws, it's difficult to find that capacity that meets that green checklist. So green, nuclear, most considered to be green, not renewable, but green, is a way for most of these heavy power consuming users to get their large loads of capacity at low carbon emitting sources. So that said, you can understand why the big hyperscalers are starting to embrace low carbon models of power development. So, for instance, Kairos Power had noted during the keynote that their small modular nuclear power plant reactors come in 150 megawatt blocks. And this allows companies like Google, per their keynote session here, to create their fleet of power plants on different sites as they grow across the country and potentially around the world. Now, what I want to be able to do is just kind of talk into some of the overall tracks that came from data center world other than the keynotes. Um, now, Bill Kleiman of Apollo, who coordinates the annual data center surveys for Data Center World, he put on a master class called Data Centers 101. I went into the session briefly just because I wanted to see what the turnout was and see some of the actual slides en route to another event. And what was really interesting is that, I don't know if there was 3,500, 4,000 people at Data Center World this year. In this particular session, it did a show of hands how many people were first timers. In the Data Centers 101, almost every hand went up. There's my guess is maybe 400 people, 300 to 400 people in the actual room, and so it just shows there's a lot of interest in the actual world of data centers. But in this particular session, what I found of interest is that Bill referred to synergy research groups, noting that we currently have over 1,000 hyperscale data center facilities. Now, remember, a hyperscale data center facility is not your mom and pop data center facility. These are all huge, heavy power consuming facilities. And now we currently have 1,000 of those in the world, which is twice as many as there were 6 years ago. So it just shows how quickly things are ramping up. Now, 6 years ago, we're talking 2019. So just pre-COVID years. And so it just shows you how busy these hyperscalers have been growing so substantially across the country. What's interesting is that Bill identified in his session what they consider to be low versus medium versus high density type racks. Okay, so Bill in this session notified that, hey, we're talking about low kW per rack densities, or 0 to 9 kW, 0 to 9 kW per rack. Excuse me. Well, I still see most of our corporate users still deploying that 3 to 5 kilowatts of power per rack. And I'll defer when we get to the discussion point of this, defer maybe to Yeet to see what he's seeing from their corporate clients. But again, those hyperscale data center facilities, my guess is probably starting over 25 kW per cabinet. And these AI requirements going well above 400, well above 40 to 60 kW per rack. Now, we're also getting some new definitions, some updated definitions of what things are, such as like an edge data center facility. Now, you guys may remember, if you've been following our different sessions, that if we go back to the 2023 State of the Data Center Survey, 64% of survey respondents to the annual survey, annual AFCOM data center survey, 64% say that they needed their maximum data center latency between any two of their data center facilities to be at or below 20 milliseconds. Now, you got to remember, Los Angeles let me use LA as our kind of rule of thumb here in Southern California, but LA to Phoenix, Arizona and back is anywhere between 8 to 11 milliseconds round trip latency based upon whose fiber routes you're running. LA to Vegas and back is about 8 milliseconds, 8 to 11 milliseconds round trip. LA to Salt Lake City back is about 18 milliseconds. LA to Denver and back is about 27. So Denver is going to be too far for the majority of companies to operate their facilities effectively. It's just too far from a latency standpoint, which is why you're seeing a lot of the activity of these hyperscalers being in that Salt Lake City marketplace where they can get affordable energy with still low latency service to Southern California, and even more of that demand in nearby markets like Phoenix, Arizona, if that makes sense. So back to this definition. What is an edge data center? Well, an edge data center facility is that smaller scale data center facility that's located closer to the end user devices it serves. Edge data centers, to me, it's a software as a service play. Trying to get those low latency applications close to the end users while you have larger hyperscale type data center facilities in markets outside of California. So, for instance, a lot of people consider Los Angeles now to be an edge market because our cost of power is higher here. We have higher seismic zone risk. A lot of our corporate clients, the constituents you saw in that second slide, a lot of those companies have smaller bits of data centers here and larger footprints of data center out of state. This is another session that was right at the end. I didn't see any slides from this yet, but this is an excellent example of Geico. Their move originally to, like a lot of corporate IT teams did, is they actually migrated their platforms to public cloud only to realize, wow, that was really expensive. And there's a migration back, and that migration back, not in full, but in part, is what we call repatriation. And repatriation is a very big topic right now. And this was a case study example of Geico that they gave a data center world. Again, I haven't seen these slides on this yet, but I put the actual description there for you. Now, the last thing I want to do before I kind of turn it over to the board for open discussion is to talk about the current 2025 State of the Data Center report that was issued at Data Center World. Again, I already mentioned this earlier, but it was noted in the report as well that colocation vacancy rates, again, so we're on the same page. Colocation is in essence multi-tenant data center space. Okay. You don't necessarily want to go out and build your own data center facility if it's a very, very small scale facility. You typically will go license colocation capacity in a multi-tenant environment, multi-occupant environment, I should say. What I found of interest is that the mean facility size for the current data center report was 32 megawatts. I would tend to think that's for some of the newer build projects, including some of the hyperscale. But I would say typically the hyperscale facilities are probably starting at about 75 megawatts and going up from there. So the 32 megawatts is certainly not including the legacy data center facilities that have been operating for the last 15, 20 years. 33% of survey respondents identified that the hybrid model is the ideal path forward, which is a combination of different types of facility assets and the way you actually deploy your facilities. Now, what I want to pay attention to here is rack density. So rack density, again, the average in 2021, so again, we're talking about just, 4 years ago, right? It was 7 kW per rack. Well, in 2023, it had grown exponentially to 8.5 and then jumped to 12. And now we're talking about building new deployments at 16 kW per rack. But for me, with that AI component, that's even going higher from there. But again, that's the AI component. That's really not reflective of what we're seeing on the enterprise user side. 79% of survey respondents are expecting those rack densities to go even higher, and 65% anticipate increased density over the next 12 to 36 months. And then the last slide I want to share before we kind of open up for our board for kind of discussion points is we already talked about, we first start off today that the limited energy supply that's out there is driving a lot of people to start looking at on-site cogeneration. By the way, there's a great book called The Grid by Gretchen Backy. I've got it right here. That's talked about how we basically started the actual power plants across the country, and how you look at the Rust Belt states, a lot of the old factories had their own coal plants and old smokestacks and what have you. Now to the point we're getting to the point where there's so much demand for power, are we going to see a shift back to on-site cogeneration? Well, again, 62% of survey respondents for this year's data center report, State of the Data Center report, said, yeah, we're considering on-site cogeneration. In fact, we just closed the deal on for one of our clients for a very, very large data center facility that has its own on-site substation. But in addition to the on-site substation, the power that we're going to be getting from the actual utility provider, there's natural gas mains coming into the actual building, which is allowing our client to come in and build their on-site cogeneration plant to supplement what they're getting from the actual utility provider. This is not just an academic exercise; it's very real and it's happening. Cloud repatriation. This is what we were talking about as far as the Geico case study, right? So in 2022, 59% the survey respondents said they were considering repatriation. In 2023, that jumped to 83%. There's a slight tick back to 71%, and now we're back to 80% of them looking to bring some of their loads back. But remember, they're looking to do this at a time where we're at all-time low co-location inventory. And so who's getting squeezed by all of these AI requirements coming to marketplace, all these hyperscale requirements coming to marketplace? Who's getting squeezed? It's the corporate user, right? So we're at a time now where there's just a lot of demand for data center space. Artificial intelligence is really driving the boat here. So what I'm going to do from here, I think we're opening up to discussion. So I'm going to turn back to my board and say, hey, listen, I want to kind of hear from you guys. What what do you guys think?
Yeah, so let me jump in there really quick, Jason, because we were talking about power and on-site power generation and some of the constraints that we're facing right now. And it's interesting because what's happening now is in the global view, you talked about the constraints on capacity, which is very much real. But then there's additional complication because we've also got cases where there might be capacity, but because of transmission line restrictions and the ability to deliver the power to new sites is also another concern. So what happens is you want to do a data center campus, and we're doing master planning of data center campuses ranging from 300 megawatts up in a single campus. Trying to get 300 megawatts to a campus, in a lot of geographies is very, very challenging. So a lot of thought is going into now the whole notion of, even if there's capacity, there's transmission constraints. And to try to get a new transmission line is no small deal because it requires right-of-way easements, and it's a very, very long, drawn-out regulatory approvals, et cetera. So it's not easy either. That's what's driving this thought process of, well, maybe we need to start generating power on site or on the campus, right? And as you do that, you start thinking about this. Now, the data center, that's a significant change. You're becoming, instead of becoming just a consumer of the energy, right? You are now becoming a producer of the energy. And that's a whole new world. That requires a whole nother skill set. It requires a whole different way of engineering and putting your facilities together. But it's kind of it's being driven by the conditions, right? And there's a lot of things to balance there. There's the notion of, if you're trying to be green and you're trying to be, low carbon, natural gas is not exactly the lowest carbon source generating power, right? But at the same time, your options are limited. SMRs or small modular reactors in concept, great, but I think the earliest deployments are probably at least 5 to 10 years away for regulatory approval. And I still have my doubts as to whether people who are uncomfortable with large diesel generator plants in their backyard are going to feel all that more comfortable with a small nuclear reactor in their backyard, right? So all needs to be seen, but all these things build on top of each other. The AI and the request for higher power density, that drives, larger campuses. Larger campuses drives constraints in being able to get the power where we need it. And that's all driving, these are all interconnected, all related to each other.
That's great. Um, So I guess anybody else from the board want to kind of jump in here and comment?
Yeah, just real quick, Jason, if I could speak to some of the rack density. Um, so, my facility currently, I think the average across the board is still about 7 to 10 kW. And that's because we don't have, AI deployments fully across the board, but the deployments that we do have that are dense are just increasing in density exponentially. So this year I brought in 3 separate systems. The first one was 80 kW racks. They were liquid cooled by CDU, an in-row CDU. And then I was bringing in another system that was 90 kW earlier this year, which is an in-rack CDU. That system replaced a 2015 supercomputer, and it was 30 racks of compute condensed into one single rack. And so that just shows, the level of density. Within 10 years, we're going 30 to 1. And then lastly, I just recently brought in a 130 kW rack, which was one of the HPE EX systems. And, at this rate of density increases, there's going to be a point of no return where users are going to have to either find new facilities or completely retrofit. So there is going to be a reckoning coming at some point.
Yeah, and I think you're actually going to find that as the enterprise users are getting squeezed, right, and the different colo facilities, that there's going to be a flight to repurpose the older antiquated, right, data center lower dense facilities to house a lot of those loads.
Yep. Yeah, and I've seen some of that as well. At the university where we've had full departments migrate out of their local data center, renovate it, and within 2 to 3 years, they're now rebuilding a new facility, which, in hindsight, it may not be the most economically efficient, but it's almost a requirement in today's day and age, because retrofitting some of those older facilities, it really won't yield the results that you need for the current AI deployments.
I know Brad isn't on the call, but he spoke of the challenges of getting parts, just any type of parts when it comes to, right, for data center builds. What's happening with that?
Yeah, no, there's extreme lead times, especially on transformers and power distribution. And so, yeah, I mean, you could probably speak to this just as much as I could.
Yeah,
But
also, right?
it's been a real struggle trying to
Yeah,
procure things
it's
in a
not
proper
gotten any
timeframe.
better. Yeah, definitely. I mean, we were talking, the conversation was originally in the COVID environment with the supply chain disruptions. We were worried about people, being able to catch up, and the supply chain eventually being able to catch up. Well, to be able to catch up, you need to have a slowing of demand, right? And that just hasn't happened. And so what's happened is that when you have like hyperscalers mass ordering thousands of generators at a time, it's very hard for even anybody else to sort of go in and get that production slot to go in between them. If you want to start talking about on-site power generation, well, that typically is going to require substation transformers. And Todd and he can speak to this, but a substation transformer, from a transmission to distribution level or medium voltage level, is probably a 2 to 3 year lead time item, right? And so from the time that you decide what size you need, what rating you need, go through the shop drawings, the planning and approval, and you place that order, you're looking at 2 to 3 years before you get that on site and installed and turned up.
And it's already fluctuated by then and grown. So
Exactly.
yeah.
And so, that's right. And the other thing about repatriation and what, Tom was talking about was, think about what Jason had said. If you remember that timeline, the early 20s, everybody's going onto the cloud, and now, we're repatriating and trying to come back. Well, think about what's happened to your data center in that period of time. You've either basically gotten out of your data center, on-prem data center, because that was how you justified going to the cloud in the first place, right? It was the, I'm going to save lots of money and I'm going to, shift my, capital costs to OPEX, et cetera. Well, the world has changed. Even if you have your data center, that data center was likely built for workloads of, 1.5 to 3 kW per rack. And now when you're going to try to come back, you need to look at a minimum of 6. So that means that, you can't come back. You can't step into the same river twice, right? So that's presenting challenges. But, that's also exactly what, some of what Thomas was alluding to is, as we start getting into these higher density racks, you got these legacy data centers. There are creative ways to repurpose them, but there are trade-offs without a doubt. I mean, it's
Doesn't
just
have the
going to
capacity
be, it's
for it.
going to
Yeah.
require a lot of thinking, a lot of planning, and different
Well,
ways of designing things.
Well, and even so, and I don't know if you can comment to those super high dense. And again, I recognize this is if each of these different organizations, if each of these different enterprise organizations are looking to onboard some type of AI platform, are they doing it themselves in their own facility, or are they utilizing a third party's service, and that has its own security issues, right? Um,
Sure.
but for if you're having an AI centric rack, it's which higher densities, this isn't necessarily something that you're cooling via air, right? This is immersion
Well,
cooling.
well, yeah, what ends up happening is if you look at it from the point of view of the physics, roughly about 20 kW per rack is about the inflection point where air alone and the conventional, air cooling is by itself is not going to be enough, right? So between like 20 to 30, 40, 50 kW, you can do some of those hybrid solutions, which are a combination of liquid cooling like rear door racks or in-row coolers, in addition to your sort of environmental or white space cooling air. But as soon as you hit that, the 40 kW per rack on average, now you got to look at liquid cooling as a primary means of cooling your data center, right? And so that's where um, high density and so forth, when you start looking at. But most enterprise users, most likely somebody somewhere along the line is going to come along and say, hey, I want to deploy a cluster of my own inference engine or some version of AI in my data center. So what's going to happen is that business group is going to come in and put in a ticket, and it's going to say, hey, I want 2-3 racks at 40 kW per rack. Now that is going to make the facility manager's hair catch on fire, typically in an enterprise data center. The good news there is that, if they have space, if they have chilled water, there are solutions that you can develop to sort of accommodate that. But we're not talking about enterprise users going in and going 100 kW and 6 racks, right? That's not going to be their reality. Their reality is more likely going to be somewhere in the 20 to 40 kW per rack, or 2 or 3 of those racks in a legacy data center. And it's a lot of ways that's actually harder to accommodate than building out a high performance computing center with 100 kW racks in scale. So that's what you're going to be up against. But you know good news is some of these legacy data centers, which had raised floor, which we were getting away from, right? For the last 5-10 years, we've been eliminating raised floors. Well, they're back because guess what? We now need to do, liquid cooling again, right? And raised floors are great for routing pipes, kind of like back before. Most everybody on this panel probably is not going to remember, but we used to do water cooling to mainframe computers, right? That was back in the day. Raised floors, that's how they got started. And they said, well, geez, why don't we use this for air
I
instead
saw
of
that movie.
water?
Wasn't it called War Games?
Yeah, but I mean, think about I joke, how in fashion they always say, everything is in fashion eventually, right? Bell bottoms came back from the 70s again, type of thing. Well, we had liquid cooling in mainframe computers and raised access floor. We said, okay, well, why don't we just go to air? We got rid of the liquid cooling, went to air cooling, and we got rid of the raised floor, and now we're going back to raised floor liquid cooling again. It's just at different scale.
Maybe it'll be good for the commercial industry again. Those large buildings, right? Just cool all the bottom floors.
Yeah,
Well, actually, what
I'd
ends
like
up
to.
happening is a lot of times with facilities that have constraints like floor to floor, slab
Mhm.
to slab constraints, um, liquid cooling kind of is a way for you to hedge your bets against that, right? Because if you don't need as much headroom for your, cooling infrastructure, you can sometimes use some of those smaller, floor to floor clearances to do some liquid cooling, and it's actually a solution that can work sometimes.
With
Yeah, I wanted to jump in. We do have a question that came into the Q&A, which I think is a great question. And before I read it, I wanted to, dovetail a little bit on what you was saying around cogeneration of microgrids. And, one of the challenges I think we have here in California is this regulatory environment. And we have these state mandates about green energy and renewable. And in the utility space, that becomes challenging because there is obviously a huge demand, even if we're not building new data centers in Southern California. There's just an ongoing demand for energy. And with that, it becomes a challenge to say, okay, if we go with renewable or green, then you have to complement that with storage. And so you're trying to build battery storage plants, which that's great until the people in those areas become concerned about lithium-ion battery plants in their neighborhood, and so it's a challenging environment we have in Southern California. And so I think with that, I think this question that came in is really great. The question is what is the likelihood that we will see data centers with dedicated nuclear energy generated power? And I think my 2 cents on that is probably never in California, but I'll let some of the experts, on the panel chime in on that. But that's my opinion on it.
Yeah, I'm going to say, my personal thoughts on this and what I'm thinking is that if at all this does become something that becomes viable, it's most likely going to be in more sparsely populated areas. We're talking probably somewhere in the middle of the country, more likely. There are some solutions that are actually centered around building data centers adjacent to nuclear facilities to begin with. So that's probably going to be more likely to happen than, sort of dedicated small modular reactors in data center campuses anytime soon. But I think, probably, and, in this industry, in this world, whenever you make these kind of procrastinations, you're likely to eat your words as easily as not. But I don't expect to see a deployment of a dedicated nuclear plant with a data center campus for at least another 5 to 10 years.
But that's exactly what Google's doing.
Well, I mean, I think talking about it and saying you're doing it is one thing, but think about this for a second. I have concerns about most of my data center operators being able to operate a natural gas generating plant. Now, what kind of staffing, what kind of adjustment to your operating procedures, who's going to basically be able to operate a nuclear plant, right? I mean, I understand, it's appealing. There's a lot of things going for it, but it's a very significant paradigm shift. It's hard enough to transition a data centers, a top-notch facilities operator team from being able to keep a data center running to being able to keep a generator and co-generator plant running, let alone to try to go to a SMR, right? And I could be wrong, and it would be I'm wrong at least once or twice a year, but this is one of those things where I have a hard time seeing this get traction and go too quickly. But
Yeah.
time will tell.
I would say you definitely need your own dedicated set of operators that are utility grid level operations. That is
But that's where you get into the problem, right? Because you have those 28 states that have the renewable energy laws, which are governing the actual utilities. So, right, for instance, if you're generating electricity for the purpose of selling that to third parties, you can be qualified as a utility, right? And that's what the RPS laws are governing, right? So, but if you're actually generating these campuses where you're actually providing a microgrid behind the meter solution to tenants that are inside your portfolio, right? Is that or is that not regulated by the utility? And if it's part of the actual rent, I don't know, right? Todd, you're the
Well, I was going to say on that
one.
one, if it's behind the meter, you can pretty much do what you want, so it would not be regulated. But you're right. If you're going to export it, now you're subject to all the rules.
So, and that, by the way, one of the challenges right now is it's not only just identifying the actual properties that actually have that capability of proximity to the actual power lines, but they're also the interconnection delays that basically, if you're generating that electricity, you want to sell it back to the grid, what you're not using, that has its own set of regulatory challenges.
And just keep in mind, even if you're not selling or don't intend to export your power, there are still regulatory requirements tied around your generating capacity on-prem that you have to worry about, especially if you're using like natural gas, because now you're essentially a power producer, not a consumer, right? And so, even if you decide you're not going to sell the power that you generate, you still have some regulatory hurdles that you got to be cognizant of, depending on the level of generation you got on premises.
Well,
Yeah.
any way you cut it, we're strained for power supply across the country. And here's the thing you got to remember too, is that last year, prior to the election, we were already talking about the statistics of 60% of US manufacturers who are looking to bring manufacturing back to the United States. And then you enter the election and the tariffs and what have you, as far as people trying to bring manufacturing back, looking for energy supply, right at the same time that all these AI factories, these gigafactories, are coming online, gobbling up all the power, and it's just we're in a pickle. We're in a
Jason,
pickle.
I would theorize that at some point, um, one or maybe multiple states will make some sort of regulatory changes in order to accommodate SMRs being facilitated sooner. And if that's the case, then we may see them before 5 years' time. But if we don't go that route and there's not modification done, yeah, I would say 5 years is probably the very soonest we'd see it.
At Data Center World, there was a Department of Energy breakout session where you had 4 or 5 people from the Department of Energy up there during the panel discussions, and I walked up afterwards and I said, "Listen, one of the best things that you guys could do is uniform the definition that each state's EPA has of what's considered to be renewable, right? Having everybody with their own separate definition, do top-down definition of what's considered what." Right? That will, I think free up some energy supply. Todd, I don't know if you have any comment on that. But
No, nothing particular on that one. But yeah, I believe that they all have different ways of measuring it, and it is kind of ridiculous. It's like what you mentioned earlier with hydro, right? And only large scale hydro do we actually get credit for. Anything small, we're not able to do it. So it really creates a constraint.
I thought it was the reverse. I thought it was that you couldn't look at large scale hydro. You can only do pump hydro, whereas the large scale hydro wasn't considered.
Right. Yeah, I got it backwards. That's correct.
Hey, so we have 3 minutes left. I wanted just to double check to see if do we have any further comments that came or questions that came in?
I don't see any more, Jason, but I think given that we've just got a couple minutes, I think it's worth just throwing out a couple of comments about AI, because that, clearly from what you shared is impacting the data center space. And we all know that there has been a lot going on in the hyperscale space. I think as an end user, my perspective, certainly in the utility space, which is different. I mean, we're definitely going all in on it, not necessarily as in what we're doing from a compute standpoint, although we do partner with hyperscalers and others, including, what Thomas does there at the Supercomputing Center. The meteorology aspects of the utility space is huge in understanding weather patterns. And so that's a prime opportunity for AI. And then I think just overall, businesses are seeing there's value in having employees work more efficiently. And so generative AI, ChatGPT and Copilot, there's, obviously some risk about putting things in there that could be not public information or proprietary. But in the same token, there's a lot of opportunities for leveraging, expediting things like coding and other things that tend to be more labor intensive. So I think it's exciting, and I think certainly in the data center, and technology space, it's going to continue to be huge, and we'll probably be driving a lot of the growth that we'll see in the next decade.
Well, listen, we have reached our hour. I want to thank our board for all of their continued efforts in making this chapter go. Again, this is being recorded. It'll be uploaded to our YouTube channel, and we'll put some of the slides onto our LinkedIn page and so forth. So thank you, everybody for your time, and we will look forward to seeing you on our third quarter event.
Thanks, Jason.
Thanks,
Have a good day.
Jason. Take
Thank you.
care.
Take care.
Bye, everybody.
Bye.
Thanks, everybody.